Okay, let's get started on our video on basic integration rules, and these are more advanced type of integrals here. I did put in inverse trig identities for integrals. This was on a previous video, but I did want to put them in here because they're going to appear a lot on these notes. So I would definitely get those down or get those out so you can look at them as you're going through this. So a couple of techniques here for integration. I'm not going to read through every single one, but some of these we have done before, such as rewriting our integrand so that it becomes integratable. One that we'll touch on today, separating the numerator. Completing the square, that's going to be another big one, and that's going to involve the inverse trig stuff up here. You can also use long division here to figure this stuff out. So lots of stuff that we have talked about, some of it, haven't talked about some of it. So we'll go ahead and tackle the big important ones in this video. So let's do it. So let's go ahead and look at this first one right here. Now, I can't use a u sub because the u sub is not going to help me out, okay? Because I'd probably let the bottom equal to x squared plus 9. Then I would get du would be 2x dx, and that's not going to be able to knock out an x squared. I could also do integration by parts, but again, since this is on the bottom, this gets a little bit weirder to find the antiderivative of. So it's just going to get kind of messy. So if you notice here, my powers are the same, okay? And that's usually going to be my big old hint. The big hint to do a little bit of long division. So if I do some long division here, so if I do x squared plus 9 divided by 4x squared plus 0x plus 0, I just write those as placeholders whenever I do long division. That should make it just a little bit easier to figure out. It's going to rewrite this for me in a way where, oops, sorry, I didn't see that right there. I should rewrite it in a way where it's a little bit more easier to do. So what times x squared gives me 4x squared? 4. So I'm going to get 4x squared plus 36. And then I subtract those to give me a negative 36 as my remainder. So this is how this is going to rewrite as. This is going to rewrite as the integral of 4 minus 36 over x squared plus 9 all dx. And once I'm here, nothing bad, okay? It's all going to come from formulas. So what's the antiderivative of 4? It's be 4x. What the antiderivative of this? 36 over x squared plus 9. This is going to come to those trig inverse stuff that I was looking at right here. And it's all going to come right here. Now I have that 36 in front. I'm just going to pull it out. No big deal. But I have the a squared plus u squared. So I would go ahead and do that. So yeah, I understand that it's u squared plus a squared here, but not a big deal. In this case, I'm going to get a to equal 3. U is going to equal my x. So it's nothing that's weird that's going on. So I'm going to get this minus 36. I'm pulling it out in front. Now I really have this integral here. So I'm going to go ahead and just do my formula. My formula was going to be 1 over a, which is going to be 1/3. And then it's going to be arctan of u, which is going to be my x, over 3. And then plus c. And then just some minor cleaning up. 4x minus 12 arctan x over 3 plus c. And there you go. That's it. It's not too bad. So again, it's the first step is recognizing you have to rewrite it. Okay. Let's go to another example here. So we're looking at this. It gets a little rough around the edges here. I can't do my long division, right? So it kind of sort of looks like it's an arc something. This one looks like arc sine. So what if I just split up the denominator, make like a beaver, and split? So let's go ahead and do that. So this is the same thing as the integral of x over root 4 minus x squared plus 3 over 4 minus x squared. I'll put dx's in each of these. And this is the same thing as this, because I'm just taking this x over that plus this 3 over that. And this is going to work out for me. Okay? So now I just have two separate integrals to find. This one is actually going to be the easier one, because this is going to come straight off of a formula. And this one's going to require just a wee bit of work, which is going to be a u sub. So if I focus on this one real quick, I'm going to let u equal 4 minus x squared. So I'm going to get du equals negative 2x dx. So I'm going to get negative 1/2 du is equal to x dx, which is going to replace this x dx with a negative 1/2 of integral of u to the negative 1/2 du. So I'm just making that 4 minus x squared square root of that on the bottom into a negative 1/2, replacing that with the u. So now what I'm going to do here is integrate, which is going to end up giving me it should be a 2, right? Yeah. I'm going to end up with a 2 here. So negative 1/2 times 2u to the 1/2, which is going to become negative, and then instead of u, it's just going to be 4 minus x squared. So that's this half. And on this one's just as simple as, well, this is really just plus 3 dx over 4 minus x squared, sorry, root 4 minus x squared. And once you're there, again, go back to our inverse trig. This is just going to be arc sine of u over a. So this is going to be plus 3 arc sine of my u value is x over a, and the a is going to be 2 squared, which is 2. And then it's just this plus c. Okay, so really this is just two separate integral problems to put into one. So two techniques that we learned here, two relatively common techniques that we would do here. And then let's go ahead and get to one that is kind of not common. This one is one of the harder ones to spot, but it's more or less typical with this exponential one. So if we're looking at this right here, I think all of our techniques, u sub, you're left with an e to the x, it's not going to work. Go ahead and do my integration by parts. You're going to end up being stuck because it's in a fraction with the 1 plus e to the x on the bottom. Nothing to expand, nothing to just separate. Can't complete any square right here. Can't do division. Can't rewrite this because it's already kind of basic. So we actually need to play a little bit of a game of, hey, let's add something and then take away something. All right. So this is, what if I do this? It's a magic trick. All right. So I'm expecting you to see it coming. So it's going to be 1 plus e to the x. So this is going to be 1 plus e to the x minus e to the x, which is totally legal because this really is equal to 0, right? I'm just adding in a 0 value. Now, because of this, now I can separate this into the integral of 1 plus e to the x over 1 plus e to the x dx minus integral of e to the x all over 1 plus e to the x dx. Once you do that magic trick, we got this. But you gotta know the magic trick. Okay, so once we're here, this just equals 1 over here, right? This just equals dx, which is going to give me an x value. This guy right here, do a little side work, is going to be u equals, that bottom one, 1 plus e to the x. So du is going to equal e to the x dx. So this is going to give me minus du over u. And what's the integral for du over u? This is going to give me ln of u. Well, this will always be positive, so I need the absolute value. So this is going to be minus ln of 1 plus e to the x plus my c. So this one is definitely a tougher one to recognize. Once you do this trick, though, you're good to go. And this is more or less typical for these e to the x functions, all right? separate these a little bit. Okay. All right, last but not least here, I have cotangent of x times ln of sine of x, which this one actually is not that bad. Looks like it's ugly here, but a u sub will actually work. How do I know that? Well, if I let u equal sine, I'm going to be stuck with an ln of u. It's not going to cancel out cotangent. If I let u equal cotangent, it's not going to knock out an ln of sine. But the derivative of an ln of sine is actually pretty easy to do. So if we were to let u equal ln of sine of x, that's just going to be du equals, well, the derivative of the inside is going to be cosine of x times 1 over sine of x dx. What is cosine over sine? Well, it's just going to be cotangent of x. So this just becomes u. So this is going to give me u du. Super straightforward now. So we're going to get 1/2 u squared plus c. So it's going to be 1/2 ln of sine of x. And this is what's being squared, not the sine being squared. So you can't, there's no ln rules you can use here. Plus my constant of integration. And there you go. These are just 4 techniques. This one, just use u sub because it will work most of the time, believe it or not. But here's some other tricks that we can go ahead and do to solve these problems. That's it.